Okay, I'm going to get started with the introduction here. I know we have some more people coming in, but I'm also going to lower my microphone levels a little here. There we go. So, yeah, welcome to Kopernik Observatory, everyone. We're happy to have you this evening for one of our Friday night public programs that's part of our March to the Eclipse here at Kopernik. So March to the Eclipse is our series of eclipse science and safety and information that will lead you and prepare you for April 8th. And before we get started with tonight's program, which is on the great Adirondack Eclipse, I just want to let you know of some upcoming programs. So next week, for example, we have our second session of Family Friday, and that's going to cover some neat eclipse activities. You can make your own solar corona and build your own Earth, Moon, and Sun model to help build your understanding of the eclipse. And we'll also have planetarium shows going that evening as well. We will offer one planetarium show at the end of this program too, if anyone wants to tune into the eclipse show. So that's an option there. The remaining 2 Fridays will also be eclipse programs, and the next one's going to be the eclipse in context to the spring skies. So what's going on in the spring skies both during the eclipse and just during the night sky as well. There's some interesting things that you might see if you're in the path of totality, which will be neat. So we'll have that program, and then following that, we'll just do a final April 8th eclipse outlook. What's the weather look like? How can you practice safety during April 8th and just observing the sun in general? So we've got lots of plans there. So one last thing, if you are not a Kopernik member here at our observatory, that is an option to look into that will offer free admission to programs like tonight here at Kopernik on Friday nights. But also, you get access to the ASTC organization and set of museums and science centers across the states. And more often than not, a Kopernik membership would give you free admission to those locations as well. And there's a whole massive list of hundreds of organizations that you can visit. Just as one example, Intrepid Museum in New York City, where you can see one of these, but the real one. That one you would be able to get into with our Kopernik membership. So lots of options there too, and you can always ask us after the program or go on our website, kopernik.org, to learn more. But without further ado, we are here to learn about the great Adirondack Eclipse. Today we have Seth McGowan, the president of the Adirondack Sky Center and Observatory. So we welcome him, and I'll pass the mic to you.
Okay, thank you very much. Well, okay, I'm loud. All right, that's probably better. All right, well, thank you, and thank you for having me tonight. It's a great pleasure to be here. I've lost count, but I think this is the number of presentations that I've done on these is now into the mid-50s someplace, and I'm just so happy to do that because I believe that we should be demystifying the universe to everybody, and that's part of our goal at the Adirondack Sky Center. But I had the chance to tour the facility with my good friends George and Art today. What a fantastic place this is, and I'm just so tickled to be here. Unfortunately, for the very first time. I wish I had been here years ago. So for our online friends, if you're viewing from remote locations, please make sure you come by and take part of the wonderful activities that go on here. Anyway, so the Great Adirondack Eclipse. My name is Seth McGowan. I am the president, and my history is pretty simple. I started as a music teacher and ultimately became the technology coordinator in our school district in Tupper Lake. Became an administrator and retired just a few years ago as superintendent of schools. So one of the things the reason I mention that is not because of all of the glamour behind that, but because nowhere in there did you hear me say anything about taking a single science class ever or teaching a science subject. And that's important. That's part of my message to everybody when I do these talks, is that you don't need to have an advanced degree in astrophysics to understand and appreciate where you are in the universe. And I can't overstate that. If a guy like me can do it, anybody can do it, from enjoying viewing to astro imaging. Anyway, so what are the key factors? And the reason that I refer to it as the Great Adirondack Eclipse is because it's the first time in hundreds of years that it's come through the Adirondacks, and we are the only astronomy-based organization in the Blue Line, in the Adirondack Park. So we're a little bit obligated, I think, and it's incumbent upon us to create a sense of excitement about this and teach people about the eclipse that's coming up. But why did our observatory come to Tupper Lake to begin with? Well, first of all, that's where everybody who started it lived, so that makes a nice geographic convenience for everybody. But here's a dark sky map, or a light pollution map, more correctly, and you can see that we are right in the middle there. We are what I refer to as the heart of darkness. The Adirondack Sky Center is right in the middle of that, and on the signs for Tupper Lake that come in, at least one of them says, Crossroads of the Adirondacks, and that really just means we're farther away from everybody than anybody else in the Adirondacks, and it means it takes longer to get supplies if you need them. But what's really obvious is this ring of light that we get from from Ottawa, Toronto, New York, Boston, Syracuse. All of this light pollution surrounds this one center area, and on any given observing night, we have people from all of these areas come to enjoy the dark skies, and we are in the process of looking at becoming a designated dark sky area. So that is you couldn't ask for more than that, right? That's a thing of beauty. But again, look at all the cities that come. So again, our idea is to make the universe accessible to everybody. Again, no astrophysics degree necessary. Just be part of it and enjoy it more than anything else. We have a number of outreach programs that we do. We do free public observing. This is actually not that long ago. We start outside with a presentation similar to this, short but similar to this, and we explain what it is that we're going to be looking at in the night sky. And we have a telescope inside, a RASA telescope, that is live video, essentially. And we slew from object to object, and we show people live what they're going to be looking at in full color, and they can see what it is that what they're looking at. Because when you look through a telescope, sometimes it's that fuzzy little blotch that you're not sure what you're looking at exactly. This gives you an idea of what you're going to look at. And then we go inside the building, and inside there's 4 high-power telescopes, and we look at those things, and we explain more about what they are, and we kind of go with a theme of globular clusters or planetary nebula, whatever it is. So that's our public observing program, and it could be anywhere from in the middle of January when it's 20 below, a handful of people, to the middle of summer, and there could be 200 people there. So it's a lot of fun. We also do free private star parties. This is just a birthday party for this kid. He's 13, and his parents bought him an evening of astronomy with us, and that was a lot of fun. I had about a year ago a group from Harvard. They were PhD candidates in astrophysics, and I've never been more nervous. Right? What am I going to teach these guys? Remember, music teacher, right? What am I going to teach these guys? Well, they had a ball, because they said they never look through telescopes anymore. They sit at desks and look at data on their screens. So they had a great time, and I was greatly relieved. They liked us on Yelp and everything. Another one, not that long ago, we had a gentleman who wanted to propose to his girlfriend. So he bought a night, and at the end of the night, he did the whole thing, got down on a knee and proposed. And of course, I tried to photobomb as many of those pictures as I could get. We have our Starlab Planetarium. Kopernik does the observatory programs. We take these to schools all over the Adirondacks. And this is just gives them an opportunity to see the night sky during the daytime. We take over a room for a week, and we get every single kid in the school in there. Other STEM activities that we do throughout the school year with the kids. We have scout programs. We have after-school and summer programs. This is actually a telescope-making family event that we did. And this little girl came up to the observatory that night and saw the rings of Saturn through that telescope that she made that afternoon. And if I could replicate the sound of her voice when she saw that, it was unbelievable. We also do an annual astrophotography conference, which George and Art come to regularly and help with. In fact, is that Art in the back there? No, sorry. But it's an immersive experience. So if you have any interest in doing astrophotography, whether you're a beginner or an advanced user, we take you to the next level. The reason that the program was developed essentially like this is because when I was learning astrophotography, in the Adirondacks, it's frequently 20 below, and I remember being out in a field with my mount and my camera, and something wasn't working right, and I was trying to look it up on YouTube, freezing, and of course everything is metal, so your hands get cold quickly. So I created this event where it's just hand over hand using your equipment, your cameras. We go in, we process. It's a great experience, 4 full days. For $300. Anyway.
Seth, I'd just like to point out 2 things. Number 1, that's my Milky Way shot.
Oh, yep. There you go.
But number 2, this is a great program, and the thing that's different at Upper Lakes Imaging Conference is
you actually get to do imaging under really dark skies. So you can use your own equipment, or you can use the observatory's equipment. Hopefully you get one clear light. And thanks to Seth setting up the computers in the high school with all of the latest image processing software, you get a chance to process your images there with experts that don't include me, but other people that can help you out with the software.
Everyone has their superpowers. Yeah. All right. Thank you, George. We also do, we had a live lecture series very much like this, but with COVID, we went online and multiplied our audience by 1 million. We have regular viewers tuning in from all over the world. First Thursday of every month at 7 o'clock, suspended until after the eclipse. We have other things to think about up until then. We'll pick up that again in May. And here's just an aerial picture of our roll-off roof observatory, which I understand Kopernik is also developing a plan for. Something like this. And that roof, 4,000 pounds on a motor, just rolls right off. And when we're done for the night, we just roll it back on. So all of the telescopes inside have a full, beautiful view of the sky, of the dark sky. This is a daytime shot, by the way, if you hadn't noticed. And on our property, the beauty is that that's our location of our current telescope. We have 6 acres there. We're planning a planetarium, to build a planetarium. And it'll be on that property. It'll have a very traditional look classroom, very much like this inside with all of the multimedia and other gathering areas, very traditional dome style planetarium, and this is what it's expected to look like. So we'll be one of those rare places in the universe where there's a planetarium and an observatory paired together. Don't get that very often. Usually, like Kopernik, an observatory is at the top of a mountain, right? And planetaria are usually in the city, Boston, Rochester, New York. So they're not often paired together, but we'll have this great pairing of them together. Anyway, that's my spiel about who we are and what our goal is. But we're here to talk about the April 8th, 2024 eclipse. And tonight we'll kind of break it into a couple of segments. We'll do a little bit of geometry about the physics of the eclipse, about the motion of the eclipse and what it's going to look like. And then we'll talk about the experience of an eclipse, because if you haven't been in totality, it's a life-changing event. At least it was for me. And then I'll talk a little bit about what we're doing in Tupper Lake, because again, you'll hear me say a couple of times, we're the only astronomy-based organization in the Adirondack Park, so we're doing it big. Go big or go home. Our event we're calling Totality in Tupper, and we've made some major media publications already, including Forbes and other big mentions in the world. But let's start with how eclipses are made and why in particular 2024 is going to be different. And this is genuinely going to be different than other eclipses. But let's start with some of the mechanics first. First, the difference between a solar eclipse and a lunar eclipse. The solar eclipse is, well, the word itself, eclipse, is not necessarily an astronomy term. It's a vocabulary word, right? It just means to get in the way of something. So when you eclipse someone's view, that could be at a baseball park. It could be right here. If I stand in front of somebody, I eclipse their view. Well, that's what the moon does. It eclipses our view of the sun. Hence a solar eclipse. It is eclipsing the sun, the sol. So it's a solar eclipse. Now, one of the things I have a problem with in astronomy is the name of a lunar eclipse, because that feels counterintuitive to me. In a case of a lunar eclipse, it's the Earth eclipsing the view of the sun. So shouldn't that be a solar eclipse if you're standing on the moon? Right? But we call it a lunar eclipse because our shadow, instead of the moon's shadow on Earth, it's the Earth's shadow on the moon. So it's a little bit counterintuitive, but that's the difference between the two types of eclipses, the solar and the lunar eclipses. And we had lunar eclipse not that long ago, right around here. And there's a variety of different types of solar eclipses also. We'll talk about those also. So the ingredients, if you think of it like a recipe and how you make a cake or do a little bit of math, there's a couple of critical elements in what make a total solar eclipse happen. And they are, in no particular order, the Earth, of course, is not on a perpendicular orbit around the sun. It's 23.5 degrees tilted, right? So that is an element of where the eclipse happens, not necessarily that an eclipse happens, but where it happens is a result of that 23.5 degree tilt. Also, but directly responsible for a solar eclipse is that the moon's orbit around the Earth is not. The Earth takes about 365 days to get around the sun. Not exactly. Again, we just had a leap year, so good for us. We're over that hump. We made it. And it's not an exact number, but 365 about-ish days. The same can be said of the moon. It's about 27, 28 days orbit around the Earth. And I'll show you what that looks like in a time lapse. So the Earth around the sun, the moon around the Earth. They're on a clock. And those two intersect at certain points. There's another very critical factor in a total solar eclipse, and that is that the moon is not always the same distance from the sun. Sometimes it's a little closer. It's an elliptical orbit. It's not a perfect circle as it goes around. In that ellipse, sometimes it comes a little bit closer, sometimes it's a little further away, depending on where it is in its cycle around the Earth. And equally as important is that sometimes the sun and the Earth have the same problem. Sometimes the Earth is slightly farther away. On average, 93 million miles. The moon, on average, 238,000 miles from the Earth. Sometimes it's a little more, sometimes it's a little less. Same with the Earth, on average, 93 million miles from the sun. Sometimes a little less, sometimes a little bit more. Okay, those are key factors in a total solar eclipse and why this one is different. So first, because I'm obligated by law to mention this, the tilt of the Earth is what causes seasons. It is not that little fact that sometimes we're closer to the sun and sometimes we're a little further away. Essentially has nothing to do with it. It's the tilt of that 23.5 degrees, and you can see that tilt is constant as it goes around the sun. And in the summertime, the northern hemisphere is tilted towards the sun on the 23.5 degree, and the sun acts like a heat lamp, just like McDonald's when the hamburgers are right under that heat lamp, keeps it nice and hot. In the wintertime, the northern hemisphere is tilted away a little bit, and it's the southern hemisphere that's getting blasted by the heat of the sun. So that's the seasonal change. It has nothing to do with where in the orbit we are. Okay? All right, so that's all about that. I'm just, like I said, obligated by law to mention that. Again, a depiction of the moon's orbit versus the Earth's orbit around the sun. There's that 5.14 degree tilt, and this is a little bit, exaggerated for drama, we'll call it. Again, the Earth does not go around the sun evenly 365 days, about 365 days around the sun. And the moon takes its about 27-ish days. And you can see this animation in the middle on the bottom there. You can see as the moon completes that phase, it's a little bit closer to the Earth down there. This moon is actually getting a little bit larger. But as the moon completes that elliptical path, now you'll start to see that distance start to shrink. From 39.7, it'll start to shrink a little bit. Actually, no, it's going farther away in that case. It was closer down there. Now it's a little bit farther away. And we'll see the new moon appear. So there's just sort of a nice animation about how that works. But again, the moon's distance from the Earth is a little bit different depending on where it is in its orbit. On average, 238,000 miles, sometimes a little closer, sometimes a little farther away. Same thing, sun, sometimes it's a little closer, sometimes it's a little farther away. Now, in regard to the moon, sometimes we think that the moon, they call it the supermoon. And I know that there's reasons for that. For all of the names of the moon, the blood moon, the wolf moon, the salamander moon. They've got names for every type of moon. I think it's a miracle that the moon exists to begin with. I don't think we need to give it special names all the time. But we refer to the supermoon as when it's at its closest approach. And like anything else, as something gets closer to you, it appears relatively bigger, right? As it moves farther away, it appears relatively smaller. Its size doesn't really change, but its apparent size in the sky changes, and that's effectively what the difference is right there. So, as the moon moves around the Earth in its orbit, and as the Earth moves around the sun in its about 365-ish day orbit, there are 2 times in the course of the year where those orbits intersect. Only 2 times. And during those points, that's when we get a solar eclipse, because the moon is in the middle of us and the sun. Okay? So let's do the math on this now. Let's do it like, I think of it like a geometry proof. If anybody remembers from high school geometry, you have to, nobody? Come on, somebody has to remember how these work. Nothing. Okay, thank you. Thank you very much. So, as we said, as something approaches you, it appears slightly larger. As it moves farther away, it appears slightly smaller. So, in relationship to the Earth, to the moon and the sun, the moon has an apparent size in the sky, about 238,000 miles, and the sun has an apparent size of about 93 million miles. Now, the trick is that the moon is 400 times smaller in diameter than the diameter of the sun. Okay? So that makes a big difference. However, the sun is 400 times farther away than the moon. So the apparent size in the sky we can calculate is exactly the same on average. Right? Is that gelling with everybody? Make sense? Okay. So if you divide 93 million by 238,000, guess what number you get? Anybody? 400. Thank you. Yeah, 400. That's what makes that difference. About. So the math, that's the given. We know that the apparent size in the sky under normal circumstances, not considering anything else, is about the same size. But if we have those factors, the tilt, the orbit, that's when we get the nodes twice a year. And if we encounter a period of time where the moon distance is slightly closer to the Earth, what's going to happen to its apparent size in the sky? Bigger or smaller? Bigger, right. And so with the sun, if we are slightly farther away than the 93 million miles on average, sun appears bigger or smaller? Smaller. Key, absolute key. In that case, the moon appears a little bigger and the sun appears a little smaller. That's when we get a total solar eclipse. And this is what it looks like. The moon completely covers the surface of the sun. Okay? That is why these are rare. Now, let's do the other math. Let's go the other way, because there are times when the exact opposite is true, except for the given and except for the fact that we have nodes. Let's reverse that math and go with the fact that the moon now is slightly farther away and the sun is slightly closer. Then we get a moon that is slightly smaller than the apparent size of the sun. And in that case, we get what's called an annular eclipse. And you can see the moon can't fully cover the surface of the sun. And we get that ring of fire around the around the edges. We just had one of these on October 14th, right, in the southwest. These happen, total eclipses happen, but these happen also. So those are the two times where they're kind of reversed, or inversed, I should say. And that's why this is going to be unique. Let's kind of go through in the Far East. The sun was being eaten by the moon or something like that, and it was disappearing from the universe, and it was a big deal. We know, obviously, this is taken from a weather satellite or International Space Station. I can't quite remember. But this is just the shadow. And right in the middle, it's a little hard to see, is the darkest point. That's the total. That's when the moon is completely covering. Only right in the middle here. Let's see if I can get my mouse on that. Right in this middle section is where the moon is completely covering. From that vantage point, when you look up, you can't see any of the sun. But in this grayish area, as you get farther away from that middle, you're all partial eclipse out here. So that only in that very center is where you will see the total solar eclipse. And how does it look for scientists? Well, this is what it looks like when we get this a high dynamic range picture. Actually, this is not even a professional image as far as I know. But you can see the extent of all of the magnetic fields and all of those particles being shot out into space. As far as the physical aspects of the eclipse, if you were to draw a line of sight, and that's really all it is, from this edge of the sun across, you could see that when the moon is right there, that basically the moon starts to obscure the line of sight of the sun and shadow north into that dark area. But the sun is still shining in this bottom part. And the same thing is reversed on the top. The line of sight from that top part, if you were standing on the top part of the sun, you would be able to see that spot on Earth that's black and nothing in here. You wouldn't be able to see the sun at all in here, but you will see part of the sun here. Again, going back to vocabulary, this is called the umbra, which is the same root that the word umbrella comes from, or shade from, or something like that. So the umbra is where you will see the total solar eclipse. That's where the moon completely covers the surface and you can't see any of the sun's surface. But the penumbra is all partial eclipse territory. So that's what's happening down here. And the fact is, we see umbras and penumbras all the time. This is my living room. So you can see the sun is coming in, and it's coming in on that side. And only in this middle section, the sun can't quite reach, because of the shade right in the middle, it can't reach this dark cone. That's exactly the same concept. We see umbras and penumbras all the time. Look at the shadow of the chairs from the lights above. You can see there's an umbra right there, and there's penumbra around it. You can see it fades to gray as it gets closer to not obscuring any part of the light. And that's all that's happening. This is a daily thing, and I would invite you to look around for umbras and penumbras all the time. it's kind of fun. In terms of how eclipses move across the planet, this is from 2017. And you can see it's just a dark shadow. It started in the northwest, and it came out across the United States. First time in over 100 years that a total solar eclipse completely transversed, thank you, transversed, that's what you said. I thought you said transburst, that's a good word also. Transversed the entire, that's a good word also. Transversed the entire continental United States in over 100 years. So from the northwest to the southeast. I was in Hopkinsville, Kentucky, right here, and I chose to go to Hopkinsville. Why? Because that was the longest totality in the United States at the time, 2 minutes and 41 seconds for this eclipse. I chose to go there, as did 116,500 other people. So, but up in Tupper Lake, and here too at Kopernik and Vestal, it was all partial eclipse, right? We didn't advertise, actually. We had over 1,000 people come to our observatory in 2017 for a partial eclipse. It was about 60% coverage there, but over 1,000 people. People go to eclipses. That's sort of the deal. But let's talk about Hopkinsville. It has become the model for how communities should respond to eclipses. They changed their name to Eclipseville, USA. Their local government saw this opportunity, even though there was no real data about what happened 100 years before when an eclipse completely crosses the United States. They had the foresight to say, this is going to be big, let's do something, and they did. Eclipseville, USA. 2 minutes and 41 seconds, and I was thrilled. That was just an eternity. Totality in Tupper is 3 minutes and 33.4 seconds. So I'm not leaving my backyard practically, and I'm getting almost a minute more for that trip. And again, I went to Hopkinsville on purpose because of that totality. So we're expecting some people to come to Tupper Lake also. And these are some pictures that my wife took on the way in. We stayed in Lexington, and we drove to Hopkinsville for this. And it took us about 3 hours across the Bluegrass Parkway. 3 hours, and the last half an hour or so, there was some traffic coming in. But essentially, during an eclipse, people kind of dribble and drabble in for the days prior to, and that's what happens. So I had a spot picked out. I had a field. I did GPS, Google, maps. I was able to do live view, and I picked out my spot in this field that I wanted to go to. Got into downtown Hopkinsville. No way was I getting to that field. So my wife, who was with me, and I decided to pull into a Walmart parking lot. And it was the best decision we ever made, aside from getting married and everything. But they had water, they had bathrooms, they had food. I needed a towel to cover my camera and my telescope at a certain point. So it was a great decision. And it was jammed. We got the last parking place in the parking lot. Normally, ask my wife, when I go to Walmart, I start to shake a half an hour before I get there. I just can't take it. But I will forever be grateful to Walmart for their accommodations. So it was great. And Hopkinsville, these are not my images, but these are from Eclipseville. And they took advantage, and you can see the kind of crowds that they got. But they put on a festival, and they decked out, and that's what we're looking to do in Tupper Lake also. They really decked out. They took advantage of the opportunity, and they didn't know that 116,500 people were coming, but they thought that could happen, and they came. They actually did come. And from that one day alone, Hopkinsville made $30 million in revenue from that one weekend, or that one day, actually, I think it is. So there's a lot of economic advantage to planning for an eclipse. And again, from my vantage point in Tupper Lake, we're trying to leverage that. We know this is happening. Whether or not the Sky Center exists, whether or not Tupper Lake exists, people go to where there's totality. And we're trying to anticipate that. So we're capitalizing on the fact that we know people are coming. And when you come, my experience with my wife, we drove there, we waited, we got there way early. I didn't expect to do any photography at all, but I had the time, so I set up my camera and we talked to people. There were people from all over the South there. There was a guy from Tennessee parked right next to us. There was, couples from Georgia. I mean, every walk of life, and the anticipation. You could just feel it was like a festival environment, but the biggest festival you've ever been to, or at least that I'd ever been to, and I've been to some festivals. So it was a great experience. As the moon moves across, makes that first point of contact, hardly anything happens. You could barely tell. It's not even getting very dark. All of the action happens right at the last minute. So as the moon is moving across the surface of the sun at that first point of contact, you can feel the anticipation, right? But nothing really happens, and it takes about an hour for that moon to fully cover the sun. So during that hour, again, just like most partial eclipses, we had one on October 14th just this year, and unless you were aware of it, it was probably darker out today with the clouds and the rain than it was on October 14th. At least that's what it was like where I was. But in that case, you knew what was happening, and you were there for a purpose, and people started to get excited. And as we moved closer and closer in that hour, as it got closer and closer, the energy built. And what happens is, as you enter those last few moments, because even if the sun is ever so slightly exposed, it's still relatively bright. Right? I mean, I believe the sun, if I'm not mistaken, George Art, maybe somebody can tell me, I think the sun is technically like 1,000,000 times brighter than the moon at full moon, something like that. So even, a tenth of the sun still available is still, 100,000 times brighter than the moon, right? So it's still very bright, very light out, and nothing feels like it's happening until that shadow starts to hit you. And you feel the temperature drop. And the animals, the birds, the coyotes, the dogs, the cats, and the people swell with excitement. And you can hear the insects and the birds, and they start flying around, and it feels like chaos. And then the moment of totality, where the sun is actually fully obscured and it gets dark. And like I said, it's only that last moment or so, and it gets dark fast, and the temperature just drops. I believe it was 20 or 25 degrees in Hopkinsville that it got cold that quickly, and you feel that, and at that moment of totality, the animals go silent, and I'm not sure exactly why. I want to say it's like a biochemistry thing. They think it's nighttime and it's time to sleep, and they just go silent. All the birds, it was like a movie, like they dropped from the sky and they didn't make a sound. The people, however, the biggest cheer I've ever heard in my life. It was like a swell of whatever. I can't describe it. But in that parking lot alone, there must have been 5,000 people in that parking lot with the number of cars that were there. We were parked up on a curb illegally. And the crowd just, this unbelievable cheer, like something that they had not ever felt before. And we were hugging each other. I hugged the guy from Tennessee. I don't know if you know me at all, but I don't do that. But this guy from Tennessee, and I wish that I had, taken his address and phone number and kept in touch. But, we had a moment there. It was nice. My wife and I, same thing. There were people crying. It was just a beautiful experience. And for that moment, when you're in totality, politics, religion, economics, everything's out the window. You're all part of this crowd, this unbelievable humanity that's all experiencing the same thing together for the first time. And the thrill of that, you understand your place in the universe suddenly at that moment, in that this is happening, this massive object, the quarter the diameter of the Earth essentially, is moving in front of the sun, all independent of anything that you could do to stop it is irrelevant. There's nothing you have any control over. And that feeling is very spiritual. And like I said, crying, tears. And then for the next 2 minutes and 39 seconds, I guess, People were just in wonder. It was, you know, it was dizzying. Walmart closed their doors. They let their staff out to witness this. And if there's any business owners here that are going to be, you know, experiencing totality, think about those things. You know, make sure that your employees have an opportunity to experience that, as Walmart did. Again, you never hear me talking great things about Walmart, but they really did the right thing there. So for 3 minutes or 2 minutes and 41 seconds, it was a thing of beauty. You know, again, everybody very emotional. And then the last point of totality, and the sun appears ever so slightly beyond the edge of the moon. And in that moment, there is a little bit of sadness, a little bit of feeling of loss. And there is, again, another rush of emotion. And the crowd, another explosion of applause and cheers and crying. But this time, I think the feeling is more of loss, that you've been part of this unbelievable thing that you'll never be part of again. And unless you go to it, you'll never be part. So you have this feeling of sadness, and then, you know, again, the cheering, the crying, all of it. And then there's again this feeling of bonding that you just have with everybody around you, that all of these people have together. And it's a moment of unbelievable emotion. And then the moon moves for another hour. It takes about another hour for the moon to move across after the full totality, and then it leaves the surface of the sun, and the whole thing is over. And in that hour, you start to say your goodbyes to everybody who you're with. Now, I want to qualify. I was telling George or Art earlier, I did a talk for the Adirondack 46ers, and they're the people who climb all of the high peaks of the 46. And there were about 250 of them there. And I did this talk, and everybody, they're mountain climbers. That's what they do. So they're thinking is, what's the view like at the top of the mountain? And I said, well, it's exactly the same as it is at the parking lot down below, but you're not with anybody. And in order to really fully experience this, it's more about the people. And if you're at the top of the mountain, first of all, you have to get there in April in the Adirondacks, which is a little harsh, or can be harsh. And I think by the end of that conversation I had with them, a lot of them had changed their mind, and they decided they were not going to climb a mountain on that day, but rather be with the people, be with that unbelievable energy. So for that next hour, the moon is moving across and starting to leave the surface, and then every car engine starts. And all of those people that dribbled and drabbled in over the course of the days prior to it are now trying to get out. And our 3-hour trip from Lexington to Hopkinsville was 11 hours back. And along that route back, this is an image from the highway department there. Along that route back, the gas stations ran out of gas, and the McDonald's and all of the fast food restaurants ran out of food, and the Quickie Marts ran out of toilet paper. I mean, it was like the end of the world. It was really crazy, and just unbelievable standstill traffic. It was 11 hours. And as much as my wife and I renewed our vows during the eclipse, we divorced twice on the way home. That was just the way it went. I think we got into one fist fight and divorced twice. That's just what happened. Because it was just, we didn't expect that. But we do now. We expect it now. And the reason is because it hadn't happened in the continental United States this way in over 100 years. But after 2017, all sorts of studies have been done about what happens to communities and how to best plan for your community in totality. And it's no secret. We can predict eclipses. It's just geometry, right? It's just math and geometry. This is a map of eclipses in the past 20 years. And you can see that blue line across the United States. That's 2017, April 21st. I'll never forget it. And you can see how it came in and it went across the United States and left. But that's history, right? We know when that happened. But we can predict forward too, right? We know all of the eclipses that are going to happen for the next 40 years, for the next 100 years, the next 1,000 years. It's just math. We know where the sun is going to be. We know how fast it's moving. We know all of that. It's just math. So we can predict where all of these things are going to happen. So let me talk a little bit about why I'm very Adirondack centered in my talks about totality in Tupper, and why I refer to this as the Great Adirondack Eclipse, in that it's the first time in a long time since the Adirondacks where an eclipse has sat fully smack dab on top of the Adirondacks. It doesn't happen very often. In fact, the last time an eclipse landed on the Adirondack Park like this was in 1349, December 10th. It was cold that day. I remember I had to bundle up and put on extra. But 1349, it was the last time. Now that's not to say that the totality hasn't grazed the southern end of the Adirondack Park or the northern end, but this is fully on the Adirondack Park, and it's been since 1349 since that happened. Let's fast forward now into the 20th century. We had a partial eclipse in that vein in 1925, in 1932, in 1963. In 1994, we did have an annular eclipse in the Adirondacks, similar style. It sat right on top of us. I was in Tupper Lake. I was teaching music at the time. I remember when that happened. So that was the annular eclipse there. And of course, in 2017, when Hopkinsville and that middle path across the United States had totality, we only had 60% coverage, about 60% coverage in Tupper Lake. Still, at our observatory, while I was in Hopkinsville, the observatory was open, there were still thousands of people there. We didn't do a whole lot of advertising, but people go to eclipses. I guess that's my message. This past October, we had, while the Southwest experienced the annular eclipse, we had a partial eclipse in Tupper Lake. Less than 20% coverage of the sun. Still hundreds of people in Tupper Lake for that event. Unbelievable. But it's this one that we have our eye on. April 8th is maximum coverage lasting 3 minutes and 33.4 seconds. That is a tremendous amount of time. Eclipses can last much longer than that. But in our case, that feels like a tremendous amount of time. We're going to experience another annular eclipse in Tupper Lake in 2093. That's the next time that type of eclipse will happen. By the way, I think in 2044, another total eclipse will come across the United States, but nowhere near Tupper Lake, so I don't care about that. The next time a total solar eclipse will sit on the Adirondack Park is in 2399. So again, this is an opportunity that we haven't had since 1349 and won't have again in the Adirondacks to 2399. I'm not sure if you've been to the Adirondacks, but there's like 4 roads in the Adirondacks, right? So what happened in Hopkinsville, we're expecting something similar in the Adirondacks, but with with far less infrastructure. So we're preparing for that. We're taking precautions. But basically what it'll look like is there's the penumbra coming in, and the umbra, the totality, is only across that yellow path. The dark circle is the totality. Anything in advance of that or behind it or to the sides is only partial eclipse. Only along that yellow path is the path of totality. And you can see the entire United States is going to experience some kind of partial eclipse. Let's let that run again. It comes in over the Pacific Ocean, and that partial eclipse, it hits Mexico, and then it hits Texas, but the total eclipse hasn't even hit Mexico yet. Now the total eclipse is in Mexico. Now it's moving across to Texas and up through central United States, and then up through the Adirondacks and so on and so forth, out through the northern Atlantic Ocean. So that's the path of it. In terms of more locally speaking, this is what it looks like. And again, that path is only about 110 miles wide from the edge, the bottom edge of that yellow line, to the other side, to the northern edge of that yellow line. It's about 110 miles. So it's a very thin pencil mark across the United States as it comes up through. And you can see that that bullseye right there in the middle is where we're located. Here's again a little bit more zoomed in, and we can see we're down here, so not in the path of totality, but we'll have partial eclipse here, right? That's nothing to sneeze at. It should be just as interesting as any partial eclipse. But along that path of totality, the closer to the middle of that stripe, the longer your totality lasts. And here's what it looks like as it gets over the Adirondack Park. And it's the reason is that blue line is the center path of totality, right? That's where the totality is the longest, and Tupper Lake is very, very close to that line of totality. And the closer you are to that, the longer it is. And because it's sort of that oval shape, if you take a tennis ball and a flashlight and you hold it directly over it, you get a round circle, right, on the floor. That's the shape of the tennis ball. But as things are moving, right, that shadow starts to elongate into more of this type of a shape. So as it gets elongated, that totality lasts longer. Towards the edge, for example, down here in North Creek, they are not quite in totality here. North River, though, is going to experience about 2.5 seconds of totality, right? And the same thing is true up here. Here is Messina. They'll experience, about a minute or so of totality, but it's only in the middle on this blue line as that shadow is moving up and across. That's where the totality happens. And of course, in advance of totality, we'll have partial, right? This is the partial. And this line is the length of the totality that we'll see. So when we're in this line, if you're standing right on that line, from the time that shadow hits you right there, and let's pretend Tupper Lake is dead center on that line. It's not, but let's pretend it is. From the time that shadow hits you right there to the time it leaves right there, it's moving that way. That's the 3 minutes and 33.4 seconds, right? And it's moving. It's cooking. It's moving about 2,500 miles an hour, that shadow is. So the data looks like this in universal time. But let me break that down a little bit more. I don't know if anybody's really interested in talking about this, but I'll assume not, because it's a lot of numbers. But for us, the totality the maximum point will be at 3:26 and 11 seconds. Now, the reason we talk about maximum totality is because the sun is a little bit smaller than the moon, right? So if you imagine the moon is a hula hoop, and the sun is a beach ball slightly smaller than the hula hoop, there's a wiggle room in there, right? So in that play, the moon is moving, and from the time it first covers the surface of the sun to the time that the moon, that hula hoop, hits the other end, that's our length of totality, and then it turns partial totality again. So at 3:26, that beach ball is dead center in the middle of that hula hoop. That's what we mean by that, and it'll last for 3:33.4. So in Tupper Lake, we start at 2:12 in the afternoon at 21.9 seconds. We hit the first point of totality that those partial eclipses you'll see last from 2:12 till 3:24. That's an hour and 12-ish minutes, right? So for over an hour, you're only seeing partial eclipse, and nothing is really happening. It's really kind of hard to tell until about 3:23. In that last minute or two, that's when the action starts. That's when you can feel something is changing. And for the next, 3 minutes and 33 seconds, we have totality. And at 3:27:59.7 in the afternoon, it ends. And at 4:36, from 3:27:59, partial, and then 4:36:17.9, that's when the sun is now completely uncovered by the moon. No longer moon touching any edge of it. So the shadow itself is kind of interesting. Its total width on us is about 108.8 miles. It's 108 miles wide. It's moving 2567 miles an hour. So that is super fast. And if you have a cloudy experience, depending, again, it depends on the type of clouds, but you can see the shadow on the bottom of the clouds as it's moving towards you, and that is a phenomenal experience. I know people who have experienced. I have not personally experienced that, but I do know that you can see that shadow moving out, and it feels like like the movie Independence Day. It feels like we're being invaded by aliens or something. We're not, but it feels like we are. The ratio of the sun to the moon is 1.05115, and that accounts for the difference in that relative size in the sky. The moon is slightly larger, the sun is slightly smaller. So what did we learn from 2017? We learned to brace for impact. And remember, we really didn't have much information prior to that, but so much information came from that. The National Transportation Safety Board did study after study about all of the communities along the path of totality. They did traffic mapping of what it's like the day of, under normal circumstances, what the traffic is like afterward. And there was a couple of things that were important. Again, Hopkinsville has a population in their county of about 30,000 people, plus or minus. The mayor was very quick to act on all of it. They ultimately had 116,500 people there for that. And they were able to capitalize $30 million in revenue from that. So we've taken those lessons learned from that, and we're trying to emulate what Hopkinsville did in Tupper Lake, because again, we're the only astronomy-based organization in the Adirondack Park, so we feel it's our responsibility to do that. We know people are coming, so whether or not we existed, people will still come, but we want to leverage that opportunity for people, and we've been doing an unbelievable amount of outreach for students. We've done professional development for teachers. We're helping communities plan. I've been to countless local municipality meetings and helping them plan, doing talks just like this. I think I'm in my 50s at some point here. I've become a NASA Eclipse ambassador, and I think we have a couple here too, right? Anybody in the audience? Okay, yep.
Now I think it's going. I'm not personally an Eclipse ambassador, but we do have a couple that are in the other room actually, tuning into the stream. Sasha Zaleski is one of them. And so we have a couple on site tonight.
Yeah, so it's a NASA-based program. It was done by the Astronomical Society of the Pacific, underwent training and so forth in order to do some specific activities and so forth. So I do want to mention that there are times to wear eclipse glasses. I know Kopernik has them here, so if you haven't secured yours yet, get them. But the only time that you are allowed to not have them is during that actual moment of totality. Remember, if the sun is shining at all, it can severely damage your retina. So the proper method, and I'm sure Kopernik will agree with this, is you looking down, you put them on, then you look up. If you try to, you see the sun and it's getting there. In the meanwhile, while you're trying to fumble with them, getting them on, you've already caused retina damage. Cell phones photography is pretty easy. You can buy film to put on your cell phone. You can use the Eclipse glasses for your cell phone even to take images of the sun. During totality, you can take it off. I will say, unless you're a professional astronomer or extraordinarily knowledgeable, don't use telescopes or binoculars or any ocular device unless you're with somebody who knows how to do it. There's a video. I shouldn't say this because there's kids here, but online there's plenty of videos that show what can happen to an eyeball if you even like that, looking through a telescope or binoculars at the sun. It's just not worth it. A friend of mine was slewing his telescope without a lens cap on or a filter on, had the eyepiece cover on, and within a split second the cover on his eyepiece just melted. It just a big hole in it, and it just destroyed the eyepiece. So again, very cautious. I know that there's people who ask about welders masks. Eclipse glasses, what are they, $3? Splurge. No need to take a chance with with welders masks that may have scratches on them. It's not worth it. But anyway, I believe there is a number that is acceptable. I want to say it's 14. I don't know if anybody, 14, there you go. that's acceptable for welder's mask. But again, you know, splurge. It's a once-in-a-lifetime event. Might as well. Anything I missed in terms of eclipse safety? Viewing safety? Okay. We are providing eclipse glasses to all of the school districts in our region. The Adirondack Sky Center Observatory is doing that, and that's part of our outreach. We've purchased so many of them that we got them for so little cost. If you're interested, or if Kopernik runs out, which I can't believe they would, right? I mean, they've got cartons and cartons of those. So get your eclipse glasses. But like I said, we're leveraging this, and these are just some of the things that we have going on. Absolutely free. There's not a single penny of anything charged to the public for this. And trust me when I say hardly any of this is actually free. So we're spending a tremendous amount of money to do this. We're making it back with our sales of eclipse glasses, of other merchandise that's branded for this event. We've got an 18-foot digital production company with a big digital screen coming. They'll be streaming all of NASA streams that will be of interest to us. We'll stream those. We have a number of other broadcasts coming in, not just from NASA, but from other areas. We've got citizen science experiments going on at our observatory that we'll be streaming some data from also. So all sorts of events taking place. We have our NASA Eclipse ambassadors. We've got a couple of solar system ambassadors. We're also using NASA is using our telescopes as part of their stream also. I think there's 13 sites across the United States that they're streaming from, and we're one of them, and pretty darn proud of that. We've got a TeleVue NP101 on a Celestron mount, and it's a tandem mount. So on one side is the TeleVue, on the other side is a Lunt LS60 with an HA filter on it. So during the normal time, we'll be using the HA filter, but then at the moment of totality, we'll use that TeleVue, and so it's a wide field, and you'll be able to see the full corona, as much of it as we can possibly get in, on a very large chip. So it'll be a nice, beautiful, large image. Those are both going out to NASA. And because our production company is on site with cameras, NASA is also picking up our event, so they'll be streaming that back out on their stream. Citizen science experiments, we're part of the CATE project. We've got a radio telescope experiment going on, a couple of others. We'll have our portable planetarium. We've got solar scopes, a bunch of them for viewing. We have speakers from the Harvard-Smithsonian Observatory and Wesleyan universities coming to do talks for us, also interact with the crowds. What else? We've just endless food trucks, of course, for this number of people. We're expecting, 5,000 to 10,000, maybe 20,000 people. And because our observatory site is actually too small, we only have 6 acres up there. But I was the superintendent of this school district, so I said, hey, anybody want to let us use the school for this event? And luckily, they were generous enough. They gave us 2 weeks of unrestricted access. Every field, every school bus, every classroom, every parking lot, everything. And they're running power for us. We're securing a secure network for our NASA feed. So along the field, this is many acres worth of field here, but we have not only the Apollo field, but Artemis is out here, and then there's a number of other large fields here. This property can support probably 20,000 people on this property comfortably. Number of food trucks, information. These Mercury, Venus, Gaia, and Mars will host our many family activities, from eclipse glass making for kids to measuring the distance of the sun and the moon with yardsticks and solar beads, the whole 9 yards, everything. And that's going on all day Sunday, all day Monday. Two of our 3 citizen science projects are taking place right on this field here. You'll be able to engage with them. Our NASA telescope feed here will be right in this area. School is running above head power and Ethernet directly to this spot, so that we have a dedicated line right to NASA, and we're going right to their core. It's not like we're they're not picking us up on Facebook Live or something. We are streaming right into their core, and they're putting it out that way. We have a public solar viewing area with multiple telescopes, so that people can, over the course of the whole weekend, can come by and look through with somebody who's trained in looking at the sun through telescopes. It's a whole thing. Our indoor planetarium will be set up in the gymnasium, and it's just really set to be a fantastic event. All but the very last details are already in place. Again, as the former superintendent of the school district, this kind of planning is kind of in my wheelhouse. So we have 80 volunteers for this property alone, and we have other properties that we've got events taking place on also. But this is the main thing. The school has provided school buses for us, so we have designated remote parking lots set up throughout the community in large hard surface areas, and I've created a transit system so that there will be bus loops that bring people from those parking areas, drop them right off here, and they come up onto Apollo Field and take part in all of the events. So again, one of the reasons again that I'm so dedicated to this idea is because of my experience in totality before. I want to make this an experience that people will have a good time, they'll enjoy themselves, they'll be safe, and they'll want to come back to another eclipse, or come back to Tupper Lake again. If you haven't been there, it's a great place to be, but I want to generate that feeling of enthusiasm for eclipse viewing and space and being part of the universe. I guess that's our mission, just that you should feel part of the universe. And by the end of the weekend, I'm really hoping that people feel that way. So again, that's just what we're doing in Tupper Lake. It's our responsibility to do that, and we're taking it very seriously. So with that, I want to just kind of close things out with one last short video clip. A lot of people ask, well, what happens if it's overcast? What happens if it's raining or snowing or something like that? And I want to share this briefly. I won't share the whole thing, but this is in, I want to say Wyoming for 2017. And let me just give you a feel for what it was like.
That scream is because we are seeing it right now.
Cloud cover.
That is remarkable. It is different in different parts of the country, but here in Beatrice, we are able to view the sun without any glasses on because we are in totality. We are fully in the moon's shadow here in Beatrice, Nebraska. It is incredible. There is that sliver around it. Oh, wow. The light streaming around it is the corona. You are seeing the sun's atmosphere in a way we are never able to see except during a total eclipse.
So during the eclipse, because of that quick change in temperature, the atmosphere experiences very unpredictable changes. And oftentimes there's thunder and lightning. There could be hail. I don't know if you were able to see it in this one yet. It may come later, but in that earlier video, that NPR video, One Nation Under the Sun, there's lightning strikes you can clearly see. And it's still an amazing experience. It still gets dark. It still gets cold. Do you get to see the corona? No. But it's a different type of an experience. It's a little bit more eerie and frankly a little bit more frightening. So it's worth, even if it seems like you're going to a cloudy area, don't stop going. Don't not go because you feel like it's going to be cloudy. Go anyway, because what happens often is that the changes in the atmosphere part the clouds like the Red Sea. And we experienced in Tupper Lake for the partial eclipse in October, it was raining a half an hour before the eclipse. And then it cleared up. Art, you were there, right? Remember, and then suddenly it cleared. It was unbelievable. And all of those downtrodden faces, it just made that elevation of enthusiasm for a 20% measly coverage of the sun. The excitement just from that, because they didn't think they were going to see anything. So don't not go because you think it's going to be overcast. It's still an unbelievable experience. So with that, I want to thank Kopernik again for inviting me here tonight and your time. And I hope to be back again. And maybe I'll see you up in Tupper Lake at some point. So thank you very much.
All right, yeah, thank you so much, Seth. I wasn't sure it was possible to be more hyped about the eclipse, but I think you brought my hype level up a notch. So, yeah, so are there any questions for Seth from, I'll be monitoring the chat too, so any questions from the live stream or out in the audience here? Any questions about the eclipse? Yeah, I'm going to bring the mic to you, George, just so the live stream can hear as well.
Are you going to have the state police or somebody else with traffic control, getting into and out of the various small towns in the Adirondacks with those really small, narrow roads?
Well, the state police are not going to be focusing any telescopes or doing any presentations on the, on the science behind eclipse. So I'm not really involved with the planning on the state police because that's their area of expertise. They know from me and a million other sources that we are expecting a tremendous crowd, but they're the experts in that. So am I planning that? No way, because somebody would be in real trouble if that was the case. But they are, and there is a plan in place. We have on our property, I didn't mention it, but we do have an ambulance parked there. We have rescue squad there and an area for triage and so forth. So. And the local police, a lot of them I had as students in school. So, and around the NASA telescope, I'm yet to secure one, but I hope to have one of my former student police officers stand there just to be. Nobody can touch that equipment, so at least one of our police officers on site.
All right. Any other questions? Oh.
Is there any way to make an artificial eclipse and sort of see the same thing?
Yes, there are ways to do that. I mean, anytime you're playing with the sun, it's just dangerous. I mean, the moon provides a great opportunity because we know the timing of it and we know the accuracy of it. You could take I'm not recommending this, so please do not take this as a recommendation, but you could take a black paper plate that is proportionally the size of the sun in the sky and hold it up and get a similar effect. You won't see the corona because that is actually happening beyond our atmosphere. That's happening out there. But you're just in a shadow. So, in terms of really emulating what's happening during a total solar eclipse, I don't really think there's a way to do that on an average day with the corona and the full effect of the atmosphere, the change in temperature, all of that. You could certainly at any point just block the sun physically. I don't know if that answers your question or not. Doesn't feel like it.
Well, I was wondering if you could see the same effect.
The corona? You mean?
Yes.
No, I don't believe you would see that. I'm not sure, honestly. I don't know if anybody has ever tried that.
I think the SOHO satellites have an artificial disk and they image on both sides.
Right, but they're
sometimes in the other imagers.
right, but they're outside of our atmosphere, and that's what we're fighting also. So, I think once you get past our atmosphere, you would have some more success doing that. Space station, right. Catch a ride next time. There's one leaving shortly.
All right. Any other questions from our on-site audience? Oh, all right. Let me check the live stream quick and see if there's anything there.
I'd like to think I covered everything then, right?
Yeah, I'd say it looks like you did a good job. No questions there either. So, yes, thank you, Seth, so much for coming up and giving us an example of a big event that's happening at Totality. And yeah, it's such incredible information there. So yeah, if we will hold a planetarium show after this program. If anyone wants to tune into our eclipse show, that's both the partial eclipse that happens here, and you also get a idea of totality elsewhere. And if you need eclipse glasses, they are available in our gift shop. And thank you so much for coming out tonight, and we'll give Seth another hand here.
Thank you. Thank you.